Welcome to the third lesson in expectation values. In this lesson, we're going to be looking at a lottery game with a lot of different outcomes and then calculating the expectation value of this game overall. So let's consider the following lotto game. Super Lotto is a lottery game in which players pay $1 per ticket. For each ticket, the player will select 5 of 48 numbers. And then at the time of the drawing, 5 random numbers of those 48 are chosen. There are multiple events that could occur, as seen in the table below. So if you get all 5 correct, so you pick the 5 numbers and you get all 5 correct that are drawn, you win $100,000. If you get 4 of your 5, it doesn't matter which 4, it could be the first 4, it could be the last 4, it could be some combination of 4 of the 5 on your ticket. If 4 of them are right, you get $1,000. If 3 are right, you get $50. If 2 are right, you get $5. And if you get 1 right or 0 right, then you just don't win anything. So what we need to do is we need to figure out the probability of each of these events. Since we know the winnings, here are the outcomes, and the cost to play, we can use the winnings minus the cost times the probability to find the value for each of these events, and then the sum of these values will be the expectation value. So as we're doing this, a few things to remember. The EV of this game is the sum of the values for each of the events. So the expectation value of the game is going to be the value of 5 of 5 plus the value of 4 of 5 plus the value of 3 of 5 plus the value of 2 of 5, and then finally plus the value of just losing. And to find the value of each event, I use the following. The value of an event is equal to the probability of that event occurring times the outcome of that event minus cost to play. So we're going to start from the top of the table and work our way down to the bottom. So let's do 5 of 5. If there are 5 numbers, doesn't matter what you pick, could be, just 1, 2, 3, 4, 5, and there are 48 numbers in total with 5 chosen, then we want all 5 of the numbers on our ticket to match, and we want 0 of the 43 that are not on our ticket to, not show up, not match. So what we're going to do is we're going to do the following. The value of 5 of 5 is going to be the probability of 5 of 5 times outcome minus the cost. So the probability, this is what I'm getting at here. There are 48 numbers in total. So I'm going to make a fraction here. And on the bottom, I'm going to do 48 choose 5. That's the total number of possible combinations of 5 numbers from the 48. Now you could write that as 48C5, or you could write that as 48 and then a 5 here in parentheses. Note there's nothing separating the 48 and the 5, so it's not a fraction. This is just another way to write combinations. If you're more familiar or more comfortable with 48C5, that's fine too. So that's the total, okay? Total number of ways 5 numbers could be selected. From 48. Now we're going to break this up though, because of those 48 numbers, 5 of them are on my ticket, and 43 of them are not on my ticket. And of the 5 on my ticket, I want all 5 to be called. Okay, so this would be of 5 numbers on my ticket, 5 are called. And then over here, the 43 remaining numbers, well, if I have 5 of them on my ticket and I want 5 of them called here, then this would be 0 of these are going to get called. So this is of 43 numbers on the ticket, 0 are called. Now, what's nice about this is I can use my calculator for this. So in my calculator, if I'm doing 5 choose 5 first on top, then I can do this in parentheses and just say 5, go to math, over to probability, and then down to NCR. So 5 choose 5. And then that is going to get multiplied to 43 choose 0. And that's 1. There's one way for this to happen, which makes sense. If I have 5 numbers on my ticket, there's only one way that all 5 of them are going to be picked. That's if all 5 of them are picked. So the top is 1, and the bottom, this is 48 choose 5. The total number of ways that 5 numbers could be selected from 48 is this. So we've got 1 over 1712304. That's 1,712,304. That's my probability. Or roughly 1 divided by this. Okay, so that'd be 0.000000584. A very, very small probability. Now that is going to get multiplied to the outcome minus the cost. If I get all 5 right, I win $100,000. Minus, it only cost $1 to play. Okay, so let's fill this in. Let's go back to the top here. And the probability of this happening is 0.000000584. And the value is going to be this. And then times 100,000 minus $1 to play. So the value here is 0.0584. Okay, let's move on to 4 of 5 matching. Now that we kind of understand this a little bit better, I'll do that without the notes written here. So to get 4 of 5 matching, I'm going to do something similar. This will be the probability of getting 4 of 5 times the outcome minus the cost for this event. So the probability, that'll be of the 48, choose 5 on the bottom. I've got 5 numbers on my ticket. 4 of these are going to be called in order for this event to be satisfied. And then of the 43 numbers not on my ticket, well, if 4 of the numbers on my ticket were called, it must be true that 1 of these 43 numbers is called. If all 5 of them were called, then this wouldn't be 4 of 5 matching, it'd be back to 5 of 5 matching. All right, let's find out what this probability is first. So let's just do this, and then I'll just change some numbers in here. So 5C4 and 43C1. This is 215. So this is 215 of this 1,712,304. All right, so this is 0.000126. We'll round that to. Okay, let's use that. And we're going to multiply this to the outcome. Well, the outcome of me getting 4 of 5 right, I win $1,000. Okay, and then it cost me $1 to play. So I'm going to do this times the 1,000 minus 1. The value here is 0.125. Suppose we can go one more here, 0.1254. And let's fill that into our table. All right, 3 of 5. So now 3 of 5, this is going to be the probability of getting 3 of 5 times the outcome of this event minus the cost. For 3 of 5, I've got 48 numbers in total. 5 are being selected. And now to satisfy this, I've got 5 numbers on my ticket, 3 of 5, so 3 of them are going to get called here. And then of the 43 numbers not on my ticket, 2 of these are going to be called. So this will be 5 choose 3 times 43 choose 2. This is 9,030. And then, of course, that's 9,030 divided by the 1,712,000. So I'll do divide by 1,712,304. Okay, the probability of this occurring is 0.00527. So I'll fill that in to my table. 0.00527. And now let's multiply this to the outcome minus the cost. The outcome of getting 3 of 5 right, I win $50. Minus, it still costs $1 to play. So let's multiply these together. That's the probability there, times 50 minus 1. The value is going to be 0.2584. Okay, so the probability, oh no, that's the value here, 0.2584 And now we'll move on to 2 of 5. Okay, for 2 of 5, let's move back down. This is going to be the probability of getting 2 of 5 times the outcome of this event minus the cost. So the probability of 2 of 5. Of the 48, we're selecting 5 of them in this drawing. There are 5 numbers on my ticket. To satisfy the event 2 of 5, 2 of these are going to be called, and of the 43 numbers not on my ticket, 3 of these are going to be called. So I've got 5C2 times 43C3 . Okay, so 123,410, 123,410 divided by 1712304. So the probability here is 0.0721. Okay, now to find the value. We're going to take this and let's multiply by, if 2 of 5 happens, the outcome is $5. I win $5 minus 1 to play. So the value is 0.2883. Let's fill that in here. Okay, finally, to lose, this is going to be, well, really I have to break this up into 2 parts. I have to find the value of 1 of 5 and then 0 of 5. But there's an alternative. Instead of figuring out those 2 probabilities separately, 1 of 5 and then 0 of 5, I could go back up to my table and recognize that when I play this game, I'm either going to win or I'm going to lose. There is no drawing in this case. So if I've got the probabilities of how to win, 5 of 5 is this probability, 4 of 5 is this probability, and so forth, I could add those together and say that's my overall probability of winning. So let's first do that. Let's do 0. Let's see, I've got 1, 2, 3, 4, 5, 6 zeros here. 1, 2, 3, 4, 5, 6 zeros, and then a 584. Plus 0.000126 plus 0.00527, and then plus 0.0721. So my overall probability of winning, regardless of the different type of events, is about 7.7%, 0.07749. that also means I can figure out the probability of losing. If I either win or lose, those are the only two things that could happen, then I could say 1 minus the probability to win is my probability to lose. So this is 0.9225. In other words, when you play this game, you lose a little over 92% of the time. You only win about 7 to 8% of the time. Well, the value of you losing, that's going to be the probability of you losing times the outcome. I get $0, but it's still minus $1 to play. So this is negative 0.9225. So now to find the EV, the expectation value of the game. That's going to be all of these different values added together. 0.0584 plus 0.1254 plus 0.2584 plus 0.2883 plus negative 0.9225. The expected value of this game, assuming I've put that into the calculator correctly, is negative 0.192. Okay, let's fill in some of these things here. The probability to lose, this was value of lose is the probability of losing times outcome minus cost. And this ends up being that 0.9225 times 0 minus 1, which was negative 0.9225. And so there's everything filled out. My EV for this game is negative 0.192. This means a player loses about 19 cents per play on average. So there is no one scenario where you go in, you play this game, and you lose 19.2 cents. But if you were to play this exact scenario over and over and over again, 1,000 times, 10,000 times, 100,000 times, you would find that it would average out to you losing 19 cents per play. 2 questions for you to ask yourself. Would you play this game knowing the expectation value? And maybe go beyond that. Who runs lottery games? Why do you think lottery games exist? And who benefits from them? So hopefully this helps you out. If you have any other questions about expectation values, certainly feel free to let me know.